In this video, we have a lot of stuck things. We get the big drills out. And we unleash fire and brimstone. Hello, welcome to Tweed's Garage. In this video, we're continuing work on my ADLER MB250. Those of you that don't know, it's a German two-stroke twin from the 1950s, and yeah, took it out for a ride a little while ago. That was on the previous video. Had a few problems having to delve into the engine. So in this video we make a lot of special tools and do a lot of work tearing the engine apart. So let's go and have a look. So I've been looking in the parts manual for a clue how to get this clutch assembly off, and there's no actual nut within the assembly that holds it to the shaft. There's only sort of spaces within the back of the clutch, so I don't think there's anything holding it on. And looking at the crankshaft, it's a straight shaft that the basket sits on, which is unusual. I thought it would be on a taper, but it does have this thread here, which is for a puller to pull it off. Now, you could put a legged puller on the outside to pull the basket off, but you could risk damaging. There's a plate at the back that holds the back of the assembly together, and you could damage or distort that. So because there's this thread here, I suspect there is a tool very much like the tool for this is for Vespa engines, and I think it fitted something else actually on one of the Japanese bikes. But yeah, this is a puller, so it screws on there. You've got a bolt that goes in the end that rests on the end of the shaft, and you just wind it in, and hopefully it should sort of pull this off. So I've had a look at my stock pile, found this nub of steel that will do the job. So we'll turn that down so it fits within this bearing here, so it's not pushing on the bearing, just on that inner surface there, just below 30 millimeters. Needs to be sort of 30 millimeters deep to clear the shaft. That'll leave us a bit of meat at the end to drill and tap a hole to take out. I've got a UNF bolt to go in there because it's a bit finer than a metric bolt. Gives us a bit more control. And then internally bore it out. I've measured this, it's 26 millimeter diameter thread, which unfortunately doesn't come on any of my thread charts, and going in with the thread gauges, it's 1.75 millimeter pitch. So bore this out, hopefully cut a 26 by 1.75 millimeter thread, be able to screw that on there, wind the nut in the back, and hopefully slide this assembly off of the shaft. That's the plan anyway. So let's make a start. Got my stock material, got a 8.5 millimeter clearance drill, got my 3/8 UNF tap, got a 24 millimeter drill, and a internal threading tool. And then on the lathe I'll have my boring bar and turning tools. Okay, let's see if it works. Just tighten it down. And slowly put some pressure on, see what happens. Not budging. Well, what do you know, I was making a lamb tagine and thought I'd come out and have another go whilst I was waiting for that to bubble away for an hour and 45 minutes. So got the marvellous whizzy gun out and just took a run up at the Allen bolt, and it just popped straight off. So we can remove all that lot as a complete unit, I think. Yeah, foot peg's in the way and something's dropped down inside. Oh, there's thrust washers inside, so I need 2 hands for this job, but bear with. So just drop the foot peg out of the way, and then the complete assembly came off. Just got to watch, there's a thrust washer, a spacer and a couple of cup washers in there that I need to sort of poke back up in position when I slide it all back on again. But yeah, all looking like it's in good order in there. Make sure I get that needle roller bearing off without dropping it in the dirt. And then the next thing to do will be to make up a little sort of spreader plate and a couple of bolts to pull this gear off the gearbox input shaft there, and then we can get to our crankcase end caps, get them off and then get to the seals. So the little puller worked. But what you can do is I found a little video of a guy stripping one down. You can take this clutch all apart and you get a bit more thread to get onto, whereas I only had sort of 2 or 3 threads, but with the shock of the whizzy gun it just sort of popped it straight off, and it is a taper, so that'll just pop back straight on there with a little tap. We'll put that home and we reassemble it. So now we've got the clutch off, next thing to remove is the gearbox drive gear. So I need to get the split pin out, get this nut off, and then there's 2 threaded holes here for a puller to go in. But yeah, of course these are non-standard, well they're standard, but they're 7mm by 1mm pitch threads. I mean, not the standard bolts you can trot down to the hardware store and get. So I've had to turn some bolts down, put some 7mm threads on them like that, and then this will work. So this will work with one of the pullers that I've got. That'll fit across there. Those 2 bolts will go either side, and then wind that in and hopefully pop this off. So let's get that old bit of split pin out. It is a whole bit of split pin as well, just half a split pin I think, or a bit of wire. There we go. Right, that's that off. .22. No, I think it's reverse thread. Yep. There we go. Ah, there we go. So I got that off nice and cleanly. So now we can concentrate on getting these crankcase plates off. And again, they've got threaded holes top and bottom, there and there. Not sure. I've seen people wind a bolt in and push them out, you know, using the casing behind or putting a bit of packing behind, screwing them that way. These are quite delicate and can break across here, so I think I might make up sort of some plate that will go across, and then these can just be, plate can be bolted down using these threaded holes, and then either a tube over here and a, you know, puller thread in the middle to try and pull it up even Stevens. But first thing I've got to do is get this ground washer off, and it's really close to the case. I've tried easing it up with a very flat lever bar. I think it's come out a little bit. I can get round it a bit more. I'll try it a bit more. If not, I'm going to heat it up, and then hopefully it'll ease off a bit easier. Oh, I know what it is. It's not a washer. It's a bit like the aerial. It's actually a collar. So it's probably a tight fit on here. Goes through there and is the right size for the lip seal the other side. But unlike the aerial, this is a tight fit on the crankshaft, so there's no chance of air getting down there. But it is coming. Then hopefully I can get a puller on it at some time and be able to ease it out. I don't really like levering. As you can see on this case, it's scoring it up a little bit, but it's just the housing for the seal. So I think just slowly catchy monkey. Okay, to get this off, I've got my bearing puller. That just slips under that gap I've made under that sleeve. Just turned up some spacers just to move the nuts out of the way, away from this casing. Just gives us a bit of clearance. And then get them up a little bit. Okay, they're tucked in under there. Let's see how long. Yep. See, even adapted this, made some adapters and spacers so that it went over longer shafts, said the actress to the bishop. Them in like that. Seems a bit tight. I think we might have to sleep on it. Come back in more. Oh no, there we go. I think when we pop it back on, it will need warming up. Yeah, there we go. That's definitely tighter than the aerial one. I don't think there's any chance of any air leaking through that gap. There we go. Even the seagull approves. There we go. One top hat seal spacer. Very burnt. Okay, so the next thing we're going to do is undo these and try and remove this, but again I've got to make another tool, so that'll be for tomorrow. Okay, so the crank seals are turned up, plus a couple for the kickstart and gear change. So all we need to do now is be able to get those crankcase covers off. So been busy, took a bit of scaffold tubing. Yeah, if you ever got any of this kicking around or somebody gives you some of this stuff, it's bloody good stuff. Okay, it's welded tubing, galvanised, a bit rough on the inside, but it machines really nicely and it's pretty bloody accurate as well. Pretty true. I mean, it needs to be because it's, you know, certified for scaffolding. So yeah, it makes handy tooling and stuff like that. So bit of angle iron, bit of scaffold tube, sort of noggin end out of the steel box. So just turn the tube down, put the noggin in the end, welded it in, welded this to the angle iron plate, and then it's drilled to allow fixing bolts to go through and clamp it to each side of the casting. Hopefully with the casting, you know, this being screwed against the casting, it bridges that bit of that casting and adds a bit of rigidity to it, hopefully. And then from one of my other pullers, we got this threaded shaft, so that will go in there and push on the crankshaft. I'm going to see how much pressure that it takes. If it's sort of taking too much, I'll turn up a little sort of brass bucket to go on the end of the crankshaft just to stop it being damaged. But I'm hoping if we pull it straight and true, I'm hoping it will come out. Anyway, we'll get the cover unbolted, pop this on and see how it goes. Okay, let's get these off, and these are 11mm, of course they are. Okay, secure that to the castings. Just check these bolts aren't too long. No, that's all right there. No, it's okay there. Right, I'll move you around the other side. You'll be able to see better past this plate. Okay, let's see if we get any movement. No, I don't like that. It's sort of, there's movement. I know it's just pushing the crank over because there's a cement float on the crank. But I don't see any movement. Oh, might be wrong. I do believe it's coming. Yeah. And also, it's pulling it nice and squarely, but also I can move it left to right as well to help square the cases up as they come out. Yeah, it's coming out nicely. And give it a little wiggle as well, just to move it around. Oh, there we go. Yeah, see that? Just square it up a bit. It's coming out a treat. had so many horror stories about these, getting these out. Oh, I think this is nearly clear of the crankcase. That's it. I think we are clear. There we are. Oh. Bit of gunge in the bottom there. We'll clear that out. Just carbon deposits. Gonna need to make a new gasket. That's not too much of an issue. And there's the main bearing. Looks okay, but could do a bit of a degreasing and a clean up. And then, yeah, you can see the seals are looking pretty. Oh yeah, they're really hard. Now, people have said about the internal seals, I'm not going to change them for now. You need a special tool, one that I've got to sort of research a bit. Doesn't go in from this side, goes in from the other side, and you stick it through the hole here, and it's segmented like a gear. It locates into a bolt that's got a segmented, you know, geared head to it, and you pop the tool through here and undo it with the tool. You need a special tool to split the cranks, but also to get the cranks out I'd have to disassemble the top end, disturb the pistons, disturb all the gaskets. You know, haven't got any head gaskets, so for now we're going to leave the middle ones alone, just change the outer ones and see how that goes. And I'll do a bit of research on the tool we need to split these cranks. The poor deluded fool. Little at this stage did he realise that his comments would turn around and bite him in the arse. Yes, more tools are going to have to be made. Yes, this special crank splitting tool is going to need to be made, and I need to make another tool on the generator side because the crankcase closing plate has 3 holes rather than 2, just to be awkward. So I'll probably make an adapter to bolt onto the bottom of this puller to do that job. But on closer inspection of the bearings, there wasn't just the black carbon in there from yeah, this is what happens when you use either Castrol R or, I suspect, just standard engine oil in a 2-stroke rather than a sort of, you know, specific 2-stroke oil. Old sort of sulfur loaded engine oil leaving heavy carbon deposits everywhere. So I just thought the bearings were coated, but on closer inspection, when clearing the crap off of them, yeah, the rollers are, not all of them, but some of them have got pitting, obviously at some stage in its life where it's been sat. Bearings lower at the bottom have gone rusty, and then, you know, it's been run again, and then, you know, and then standing again, and then running again. It keeps getting these rust pits and then cleaning them off. So sort of the rollers are pitted, and also the collar left on the crankshaft is pitted as well. So we need new bearings, and if we're doing those bearings and those seals are as hard as they are on the outer housing, the inner ones are going to be knackered as well, along with the bearing. So we're going to have to bite the bullet and do a bit of research and try and make a tool to undo the 2 crank halves to be able to split them, take them out of the crankcases, change the seals, change the bearings, and then reassemble it all. I'm hoping the big ends are okay, fingers crossed. probably cursed it now saying it on video, but when it was running, there wasn't any sort of big end rumblings. It was all quiet. There was a bit of what I thought was clutch noise, you know, clutch bearings on the end, but probably those bearings running, you know, sort of being slightly rough surfaces, making a little bit of a rumble. So the trouble is, they're not standard bearings. Well, they sort of are, but not nowadays. They're a metal caged roller bearing, and they are marked up SKF Germany, but the part number for them, the 20MN, by the look of it, I couldn't find any sort of SKF coding that would equate to that. And that's sort of, you know, these are 1955, 56, so they probably changed the coding a few times, and, you know, European probably different to UK, etc, etc. So what I have got on the bookshelf is an old SKF bearing catalogue, riveting bedtime reading, and very useful for finding, you know, modern bearing numbers. I mean, this is still, you know, 1980, which is only a couple of years ago, isn't it? 1980 is when we're all sort of jigging around to Duran. Yeah, well, 40 odd years ago. Don't bear thinking about. I'll show you. It's got little tabs down the outside edge of the book, and you've got little diagrams there. You can see all the different types of bearings, from roller bearings to ball bearing, ball bearings, and taper bearings, etc, etc, and special ones all down the bottom. So you just sort of go into there, open that section. So we went on the roller bearings, had a little rummage through. We needed, yeah, cylindrical roller bearings. We just needed the ones where the inner bearing collar just slides in and out, doesn't have a shoulder on it. So found the codes for those. The modern sort of equivalent is an NU, I think for the 20s it's NU 204. So yeah, the sort of 20 for the inner diameter, 24 or 204. And then the next one was a 25 bore, the one that goes in the centre, and that is an NU 205. So yeah, it's all right, it's nearly the dog's dinner time, so he's around my feet. So I happened to pop down to Southampton. I was passing through, found a bearing supplier, popped in, very helpful, Acorn Industrial Services Limited down in Southampton, and it's a proper old bearing and engineering supply company. So you go in there, you've got your trade counter where you sort of, you know, they keep the unwashed the other side of the counter, and then rows of Dexian shelving with Timken bearings on in their sort of original packaging, all sitting there. They do chains, drive belts, all the Loctite products, machine oil, circlips, you know, all that good type of stuff that you need. And sort of down south, it's very hard to find places like that. So they'll be my new go-to. Anyway, I gave him the sizes, the chap there, and he had a look and he went away, come back and said, right, SKF no longer make that bearing with a metal cage, but he's found another manufacturer, I think it's NSK, which is Japanese. They make them in those sizes with metal cages. So they've been ordered, so they're on the way. So yeah, until we get those, we'll carry on taking the other side of the engine apart and trying to work out how to make this tool to undo the centre nut between two cranks. Okay, right, onwards and downwards. I'll never learn, my bloody mongrel collection of bikes, it's never easy. Okay, let's start digging into this side and get the generator off. Disconnected the battery, so we'll be okie dokie. So we've got a terminal block here, got 3 wires, need to disconnect. I will make notes as well. And then these are the two feeds to the coils, so when I wire in my new ones they need to come from here, and then a wire each from the corresponding points and condensers. So let's get those off. So this all comes out as one part, apart from the HT leads which are soldered on, so I will need to cut them off, but then it should all come out as one piece. I mean, in the parts book it shows it as one complete assembly. It must have cost a fortune to buy a new one. And be easier to run my wires into the points, back out to the coils where I know that is, so we can snip that off. The same with that one down there. So sort those out. Like so. Just hook the brushes out and use the springs against the side just to retain them. Like so. Should really mark on there my timing position. I'll have to check it again anyway, but just give us a rough idea. Down there. Okay, that should be it. There you go. Well, there you go. It's in pretty good condition. Coils look pretty good. Condensers not so good. But we're going to replace those anyway. Could probably do one on the contacts on the voltage regulator as well on the end here. But anyway, that's off. Yeah, look at the quality of that stator. Compare that to a Y-Pack or a Lucas. And again, if you saw a previous video, I'd cleaned these up, but I think that, yeah, there was oil on the around the points and that. I think this seal's gone as well, and there must be a mist of oil getting out. I think this is the remains of a failed coil where it's overheated and melted the shellac around it. And there's our 3 points we need to make a puller for. Let's pull this one out, there and there. And I've got a nasty suspicion we might need to make a puller for this as well, because there's no way you want to put a puller on this, because you'll just end up wrecking the windings on it. So need to look at this, but need to get this points cam off first. It's a deep rooted bugger. Oh, yeah, that comes off, it's keyed. Keyway on it. I will just mark it. So that's the inside. You could put this on two ways. I suspect it's could make a difference. Yeah, just remember that's the inside, everybody. I think there's meant to be a tool for getting this off, but I'm not sure how you put a puller on that. Okay, I'm going to have a ponder on this, how to get that off without damaging the windings. So, I had a little look on the internet last night and a look at the parts book, and found a solution for getting this stator off of the crankshaft. And you need a pin. So the pin drops into the hole at the end. I didn't realise it was threaded the same thread on the end of the stator as it is inside the crank. So what information I could find was you just basically dropped in a piece of steel just below the diameter of the 8mm thread, so it would pass through the thread and then rest on the hole in the crank, and then you put in another 8mm bolt onto the stator, tighten it down, give it a tap, and it should come off. Okay, so but I thought the better option was to cut a bolt down. So cut the head off, turn the shaft down of the bolt to clear the threaded hole, and then left a thread on the end, and then that will screw into the crankshaft. Put a sort of slot in the end to wind it in with a screwdriver, and then I've got clearance through the threaded part of the stator, and then I'll put my bolt in on the end, and it should pull the stator off the taper. So let's give that a go. So pop the tool in there. There you can see it goes in through the thread on the stator, and then it will get so far. I sort of measured this, you know, drop the vernier in and measured my clearances, and it will get so far, and it will be on the end of the thread, and then it will drop down to the end of the crankshaft, and you wind that into the end of the crankshaft to about there, and then that gives this bolt something to push against. And there we go. It's on a keyed taper on the end of the crankshaft. We've managed to remove it without ruining the windings. And then we just wind that out. Okay, now we need to make another tool to get this cover off. Right, back to the workshop. Okay, to create my next tool, I need a plate with 3 holes in, so I've scribed out this piece of scrap steel that I've got, a bit of trunking with the 3 hole positions, and then the outer diameter roughly. I've got to cut it out. It doesn't have to be, you know, too pretty round here. It's just that as long as those 3 holes are equidistant, and you know, the centre there is in the middle of the 3 holes, that's all we need. So I'm going to cut this out. Could use an angle grinder, but I thought we'd use the old, I don't use it very often. I think the last time I used it was to cut out coils for Mrs. Tweed, but that's another story. So we'll just use the old plasma cutter. Right, off we go. Okie dokes, find something to tap it with. That'll do. Right, just need to drill the holes. Okay, we're sort of getting somewhere now. So we've got the original puller mounted to my adapter plate, and we've had to move the position of some of the holes just a bit because they yeah, they're slightly off the measurements, but yeah, that should do. So we just sort of tighten this down, bolt this to the case, and then hopefully put the threaded bar down the end and remove the outer crankcase cover plate. Okay, let's give it a go. So we'll pop this Allen bolt inside the crankshaft so we protect the end of the crankshaft. So just go down, right, thread finishes there, so we'll bring it up a bit, lock that nut down there, pop our plate on, remember which way round it goes. That way. Right. It's all tightened down. Let's see. On the puller or pusher, screw down onto that Allen bolt. And the only trouble with the plate is we can't see much what's going on, so just go slow and steady. Just try a little wiggle. No, that's not going to come. Just a wiggle. We need a bit of pressure on there. Does that come in? Getting a bit of flex on the plate. Leave it under tension for a bit. Oh, there we go. That sounded good. There we go. Broken the back of it. Leaving that under tension for a bit was enough to pop it off. Slow and steady wins the race. Mind you, it's taken me 30 years of experience to get to this position. 30 years ago I would have wrecked this. Right, that's loose. Let's separate it from the puller. Right. Oh, yeah, no, that's all right. We're not worried about the seal anyway. And what's it like in there? As crappy as the other side. Same there, rusty pitting on the bearings. Yeah, the inner one's got some heavy pitting on it down the bottom. Yeah, this is this. See, it's like N-gauge coal or 00. What do you reckon? What's the seal like this side? The seal's not, it's still hard, but it's got a little bit of little bit of give in it, not a lot though. So that's that one. And can we see this nut that we need to make this tool for? Let's have a look. And there you can just see the sort of gear segments through the balancing hole of the cranks just at the back there. Not sure if it's in focus, apologise if it isn't, it's difficult to get to, but yeah, you can just see one of the teeth highlighted there. So we need to make a tool that will get through there and undo the crank. That will split the cranks and we can get them out of the crankcases. But first, I don't want to do it, but I'll have to disturb the heads, barrels, pistons, piston rings, gudgeon pins and all that to get the pistons off, and then that will allow me to withdraw the cranks out of the crankcases. But before I disturb the top end, I need to make one tool, possibly two, one to undo that crank bolt so we can split the two cranks, and we need to get these inner races off of the cranks, both sides and on the inside one as well. I think I might just get away with just with a cutting disc, cut a couple of grooves opposing sides on that race and get the bearing puller that I used earlier to bite into those grooves to pull these races off. Don't want to heat it, don't want to beat it, just want to get them off as easy as I can. But that'll be for the next time. So there you go, been very industrious making special tools to get the engine apart, managed to get all the bits apart without causing any damage, so that is good news. But I'm going to have to do a little bit of research trying to work out how many teeth are on that splined tool for undoing the crank nut. Anybody knows, you know, have a little count, let me know and give me dimensions as well. That'll be useful. But that'll be on another video. So until then, we'll see you next time. If you like the video, give us a little like, hit subscribe as usual. Welcome to the new subscribers, nice to see you, and to all the old regulars, thanks for coming along again. And yeah, a couple of you have chipped in to the old Tweed's Tea Fund down below. Very much appreciated, and that will be going towards new bearings for the crank. So that'll do you for now, and we'll see you next time. All right, cheerio. What's that, Jenkins? How was the lamb to Jean? Very nice. Yeah, but you don't like foreign food. Hello, welcome to Tweed's Garage. We're in... Neighbours are out, dogs are barking. Special tools to take the ADLER. In the next video, I'm going to sort of